found out with the solubility test that ethanol was the best solvent for the solute that we're using. So you have to bring it to a boil so that you can mix it with your solute and have it absorb into it. So you have to bring that to a boil. One of the things that people mess up on a lot is they forget to put boiling stones in there with the ethanol, and when it starts boiling it can cause really big bubbles that will splash up into your face, so don't forget to use a boiling stone. Anything else? I think that's it for now. There's a calculation you can do on how much solvent you're going to have to use with the amount of solute that you weigh out. We weighed out almost 0.5 grams, it's 0.4563 grams, and we figured out that we're going to have to use about 2.17 milliliters of our solvent. You don't want to over add solvent because you can oversaturate it, break up all of your solute, and then your crystallization will be less successful. You also, what we're using is ethanol, which evaporates extremely quickly, so we're using a lot more than the needed amount for boiling it, because when you heighten its temperature, it's going to evaporate even more quickly. So make sure to do both of those things. When you figure out how much solvent that you're actually going to need, the sample is going to be impure. So with our calculation, we figured out we're going to have to do 2.17 milliliters, right? So you're going to want to use under that since it's not actually all pure. So when you start putting it in, you're going to start with like 1.5 milliliters or something like that, and add up from there. Alright, so once your solvent is boiling, it's ready to be used. The goal of what we're trying to do, you're trying to get the boiling solvent onto your solute so that it starts dissolving, and then you're going to start heating up your sample. You want to put the boiling solvent over the solute before you put it on the actual hot plate. Otherwise you can burn your sample and once again not have a good crystallization yield. So first you prep your micropipette. Start by adding just half a micro to 3/4 of a micropipette full onto your solute. Mix it around, add a little more. You got to get it onto the hot plate before it starts cooling down, otherwise you, again, will not have a good yield on your crystallization. So what we're going to do now, we've prepped the solute, we put the solvent together, we've got our solution. You keep adding more of your boiling solvent until, no more, little by little, because you don't want to add too much solvent, until your solute is completely dissolved into it, but just right on the other side of that. Like I said, don't add too much solvent, otherwise it will not work. You can't get your crystals to reform. So you usually do a general rule about 15 seconds of heating in between each addition of more solvent. Just to make sure that not more is going to break down. Also, you don't want it to boil too much because you can break apart your compound. Just a slight heat. So, looks like we're boiling now. Looks like I've added enough solvent as well. Alright. So what we're going to do, because we've heated it up to the point of boiling, you want to get this off of the heat and slow down as quickly as, cool down as quickly as possible so that it can crystallize more effectively. You don't want a quick cool down. So what we're going to do after I take it off of here is put it on a book or some papers or something that can absorb more of the heat, cover it with a watch glass and a beaker so that it kind of creates its own little heat around it. So stay here. Too big. That's what we're going to do. So by covering up the top, you're going to make it so that it doesn't evaporate as quickly. And then by putting this around it, you're going to make like a little heat layer around it. So once again, it's cooling down more slowly, and then it's going to absorb through these pages, which is going to make it cool down even more slowly. So what the goal is once it gets to room temperature, after you put it like this, is you take it out, you put it in an ice bath so it cools down even to a greater extent, and as it cools you should be seeing crystals form in the bottom, and when you put it in the ice bath you should see even more crystals form. actually going yet, unfortunately, so there's a couple ways that you can induce crystallization. If it's not going, I mean, it could be due to a mistake, in which case you'll have to start over, but don't start over right away because there's different ways that you can do it. You can open up your flask, you can scratch it with a glass rod, and that induces crystallization. As you can already see where I did it, crystallization started, whereas before it was not there. So then cover it back up and wait for it to kind of come to a middle ground where it stops crystallizing, and then we'll put it over the ice bath. So you can pause. So when your solution, your crystallization gets to room temperature, you want to induce further crystallization by putting it in an ice bath. So that's what I've done here. Put it in here, let it continue to crystallize, which it looks like, you can't really see it probably, but it looks like it's doing a pretty good job of. Over here is our solvent, which is also an ice bath, because we're going to wash our crystals with it when we put it in the vacuum filtration, and you need it to also be the same temperature so that it doesn't reverse your crystallization. If it's hot, if you leave it boiling, then it'll reverse your crystallization, so it has to be cold, just like your crystals. So you left it in the ice bath for 10 minutes or so. Take it out to check your crystallization. Ours is a little bit more powdery than I would have liked, but you can definitely tell that solid has formed in the bottom. There's different variations on what a crystal can actually look like. Some of them look like little flakes, some of them look like powder, and some of them preferably look like longer shards. But this will do for what we're doing. So we're going to take our solvent and our crystals over to the vacuum filtration system and turn it all the way on. You want to prep your filter paper with a little bit of your solvent. It's prepped, it's wet, so it will stick to it. What we're going to do, we have suction. You're going to pour your crystals over your filter paper. Let that vacuum through. Want to get all of your crystals out of there, and you can do that using your cold solvent. Let that filter through for a couple minutes. Wash your crystals with a little more solvent to get that extra mother liquor off of them. But let it filter first. They're kind of hard to see because most of the stuff that we'll be using is crystallizes white.
Okay.
So this is after we've rinsed our crystals with solvent to wash off the mother liquor and let it run for about 10 minutes in the vacuum filter to get off any extra liquids off of our crystals. I put it in the fume hood to evaporate any leftover, anything at all, any leftover solvent or mother liquor, anything that might still be on it. And it's dry now, so we're going to scrape off our crystals and see how well we did. It looks pretty good. You probably can't tell in the video. I would prefer that they were a little more, I guess a little less powdery than this, although you can see the kind of crystal structure, probably not on the video, but you can see it, and that's pretty good. But usually they're a little bit either more flaky or more long, cylindrical, and these ones are not. They're more powdery. But regardless, it looks like we got a really significant yield off of it, which is good. Alright. So generally you would keep that, but I wanted to show you what it actually looks like. So this is our kind of feather-like crystals on here, and you would check to see if you've actually purified all of them by taking a melting point. If you have the proper range, a small range, then you're good, and you have successfully purified your sample. If not, then you would have to do another recrystallization. It's pretty good though, yeah?
Hmm?
Yeah. Cool.
It's like winter snow.